braking, hydraulic pressure behind each piston pushes it outwards. This forces the pad into contact with disc. The resulting frictional contact slows and stops the vehicle. See here in this figure how it works. These are the disc pads and this is a caliper that holds the pads together. So, caliper is a device in which the pistons and the pads are mounted. So, when we press the pedal, it forces the piston or moves the piston outward, that closes the gap between the two pads, and this is a position when the brakes are released, and you can see this is a disc which is free between these two pads, and this is the second case when the gap between the two pads is closed up and the disc comes in between the pads and the brake is applied. So, here the vehicle is stopped due to the friction between the two. Higher is the friction between the pads and disc, the vehicle is stopped quickly, and sometimes the brake lining gets hard and the braking is also hard, though the braking lining is there, but still the brake is not so effective. So, in this case the brake shoes has to be replaced. You can see how the brake lining or the brake pads are held in a caliper. See in the figure, this is a caliper housing. This is the frame, you can say, that holds all these things, and next is piston that moves in this caliper, and this is a boot, this is a seal. Seal means it seals the whole hydraulic system, and these are the brake pads and linings, inner linings and the outer linings. All these things are held together in a brake caliper, which is responsible for disc braking system in front or in the rear of the vehicle. There are three types, the disc and wheels. There are three types of disc brakes. Number 1, the fixed caliper disc brake. Number 2, floating caliper disc brake, and number 3, the sliding caliper disc brake. So, it is not a single caliper, because it is a design of the caliper which kind of braking is required for a particular vehicle. So, depending upon the use of the vehicle, speed of the vehicle and type of vehicles, these three types of calipers are used. Parking brakes, there are two types of parking brakes, integral and independent. In integral parking brakes, these have parts. Integral means, so both a braking system is a single system which operates by both the systems. So, this is integral system is, these have parts that are common to both the service brakes and the parking brakes. Service brakes are the brakes which we apply usually, and the parking brakes which are applied when the vehicle is parked. The arrangements are different for rear drum brakes and the rear disc brakes. A rear drum brakes, a drum brake can be used as a parking brake by attaching a parking brake. By attaching a parking brake lever to the rear brake shoe, a parking brake link or stud is placed between the two brake shoes. When the parking brake lever is pulled by hand lever, it causes the parking brake lever to pivot. The upper end of the lever forces the rear shoe in contact with the drum. At the same time, the section below the pivot forces the link or strut forward. This pushes the front shoe into the drum and applies the parking brake. So, this is the rear drum brake. Now, we are also using the rear disc brakes. Most of our vehicles are equipped with the rear drum and the front disc brakes, but in some of the high end vehicles we are also using the rear disc brakes. In rear disc brake, this is a type of caliper has a piston that can be operated either hydraulically or mechanically in large screw threads. This is hydraulically or mechanically. We can apply the parking brakes in both ways, hydraulically as well as mechanically. If the vehicle is light, we can use the brake mechanically, or if the vehicle is heavy, the hydraulic brake has to be applied. Hydraulic brake, there is a non-return valve which is incorporated in the flow system of the brake system. When we apply the hydraulic brakes, it locks or fix the position of the brake shoes or the brake pads there, and the brake remains there. It does not allow the fluid or the liquid to come back into the master cylinder. A large screw threads into a nut and cone assembly that fits inside a piston. When parking brake is applied, the parking brake cables pulls the cable, so which rotates the screw, the nut, then pushes the piston out and the brake is applied. So, this is the integral brake system. Let us see about the independent brake system. Independent brake system means it has nothing to do with the service brakes. So, both service brake and the parking brakes are independent of each other. So, these share no parts with the service brakes. A set of small brake shoes fits into the hub of the disc. The hub surface serves as a brake drum. That means, we are using two brake shoes in the same wheel. One is the disc pads and other is the brake shoes with the brake drum. So, the disc is equipped, it is designed in such a way that it has one part that works as a drum, and the parking brakes are applied independent of the service brakes. Another type is the transmission mounted parking brake. Though these are used very rare, it uses a small drum brake mounted on the back of transmission. The drum attaches the output shaft. That is, it is the drum which is attached as the end of the transmission. It may be a gearbox, and at the end of the gearbox there is a drum onto which shoes are attached, and when parking brake is applied, it will lock the whole transmission system. Very interesting next braking system is the brake system valves. So, it is very important how the brakes are applied, how the pressure is distributed, and how the warning signals are working. We are quite safe in the vehicle, presuming that the system is working well. Had there been any malfunctioning in the system, it would be displayed on our panel and get easily noticed by the driver. So, in the brake system valves, number 1 is pressure differential valve. It turns on the instrument panel, brake warning light, and if either section of the hydraulic system loses pressure, the pressure loss on one side of the piston causes it to move towards the side with the low pressure. This raises the plunger, which closes the switch and turns on the light. It is a warning light. Next is the metering valve. During light braking, the metering valve prevents the front disc brakes from applying until after the rear brakes start to apply. Disc brakes can act slightly faster than drum brakes. So, if the front brakes applies first, the weight shift to the front wheels can cause the front end to dip excessively and rear tires to skip. So, that means the rear disc brake rear drum brakes has to be applied first, then the front disc brakes. Next is the proportioning valve. It is used in the rear brake line of some vehicles with front disc and rear drum brakes. During hard braking, more vehicle weight transfers to the front wheels. As a result, less braking is needed at the rear wheels. So, equal brake pressure could cause the rear wheel to lock and rear tires to skid. It does not affect the hydraulic pressure during normal braking. However, hard braking causes the fluid pressure to go above a preset value called the split point. Split point where the pressure is released. The proportioning valve then reduces the amount of pressure increased to the rear drum brakes according to the certain ratio. So, vehicles with ABS may not require a proportioning valve. Now, there is a combination valve. Many vehicles with front disc and rear drum brakes uses a combination valve. It combines the pressure differential valve, metering valve and proportioning valve in a single assembly. So, now we are using a single combination valve that serves all the purposes of the earlier discussed 3 valves. Let us see the master cylinder. It has a single piece cast iron body with a dual reservoir. Most vehicles now use a composite master cylinder, a separate plastic reservoir. See here, it is a precast body of a master cylinder, and the plastic body is attached to the aluminum body with the rubber seals. This is a plastic body and these are the master cylinder. Some master cylinders have a built-in fluid level sensors in the reservoirs. The sensors turn on a warning light in the instrument panel when brake fluid is low. Integral and composite master cylinders work in the same way. Two pistons move back and forth in a common bore. The primary piston is closest to the firewall and directly operated by the push rod from the brake pedal. The secondary piston is ahead of the primary piston. Now, you can see the parts of this. This is a primary piston, this is a secondary piston, and there is a vent port which is ahead of the piston when the brake pedal is pushed down. So, it closes the vent port that compresses the liquid in front of this, and when the piston moves in this direction, there is a replenishing port which is here. This is a replenishing port and this is a vent port. The replenishes port allows the liquids to come in the back of this chamber, and when the vehicle brake is released and it does not come back with a jerk, and this will create a vacuum in front of this. To avoid this, there is a low pressure chamber in the back side of the piston that allows the piston move backward with some force. As I told you earlier, This is a master cylinder which has a 1 inch square area, and if the same 1 inch square area is of the wheel cylinder, the same output will be received, that is 100 pound and 100 pound. If the area is increased, in this case this is 2 square inch area, the output will be doubled, that is 200 pounds, and if the area is reduced to half, 1 inch to half inch, the output would be reduced to half. And then let us see about the brake fluid. The brake fluid, it is a chemically inert hydraulic fluid used to transmit force and motion. It is also lubricates the piston and the master cylinder wheel cylinders and the calipers. Silicon based fluid can take higher temperatures, and new silicon brake fluid can be identified by its purple color. It is about a red color, that is a purple. Brake fluids are hygroscopic, they will absorb moisture. So, moisture in brake fluids lowers the boiling point. There is a basic vacuum booster operation. Two holes in the bottom of each reservoir opens into the cylinder bore. See here, it is the basic operation of vacuum brake booster. So, here it is atmospheric pressure, here it is a vacuum which is attached to the inlet manifold of the engine, and in front of this there is a master cylinder, and this is a firewall. When we press the pedal, we allow the atmospheric pressure to come in, that forces the piston, the primary piston, with a greater force, and this vacuum also attracts the piston in this direction. Because of the difference of pressure, it operates. So, that is all from this brake system. Thank you very much.